Hello, everyone. We're gonna start just in 1 minute. In 1 minute, I shared the link and I shared it one more time. In case any of you would like to follow this workshop on your computers, we would like to invite you to install some programs. And some of them are web-based programs. So you just need to make sure you have an account. Alternatively, if you just would like to follow us along on your screen and then try it at home later, that's quite okay as well. We will be sharing slides, and next week we're also going to share the recording of this workshop. But again, in case you do want to install it before we just start some of the programs we're going to use today, I posted the link to the conference schedule, and if you scroll down, there will be prerequisites. Just to get an idea, again, before we launched into this, how many of you are planning to follow some of the steps on your computers? If you can raise your hand, would be great. Okay, at least a few of you will be following us. That's great. We're gonna make sure that you catch up with each and every step. And if you feel a little bit behind, just use the chat room to text us here. We'll pay attention and we'll stop and wait for you. All right, let me share my screen and we can start. So welcome everyone to the Social Network Analysis Workshop for Social Media Researchers. And the reason we added for social media researchers to the title is just to emphasize that, yes, there are many different applications of social network analysis in different domains using datasets from different sources. But today we're really going to focus on how do you use this particular method in social network analysis to analyze and understand dataset coming from social media platforms. But at the same time, I know some of you might not be focusing exclusively on social media. Maybe you're studying broader internet concepts, or even not internet, but the techniques you're going to learn today will also apply to your space as well. I'm Anatoliy Gruzd. I'm co-director of the Social Media Lab at Toronto Metropolitan University. And it's my great pleasure to start this workshop by introducing my co-presenters. First of all, Felipe Soares, who's a postdoctoral fellow at the Social Media Lab here in Toronto. His research focuses on online discourse, political communication, social media, and disinformation. Felipe has done a lot of interesting projects in the context of Brazilian online discussions, and now he's applying similar skills, same computational science expertise to the Canadian context and other countries as well. The next presenter I would like to introduce Deena Abul-Fottouh, and she's also a computational social scientist at McMaster University. Deena studies how social media data can guide our understanding of different societal problems, including online misinformation, antisocial behavior, and the use of social media in teaching and learning. She's currently the project lead at McMaster's Global Nexus Task Force on context, evidence, and behavior, where she uses computational techniques of social network analysis, natural language processing, and data science more broadly to study social impacts of COVID-19. And finally, it's my great pleasure to introduce Alessandro Zonin, who is a sociologist working as a social media strategy leader. He is also a TEDx speaker. Check him out on YouTube. He also teaches and conducts independent research in the areas including social network analysis, content marketing, and digital journalism. Important for this workshop, he's a co-founder of Soares online program, social media analytics program for Twitter. And why it's important, because our second module for today is actually will be developed around Soares, and Alessandro will tell you all about it shortly. But first, let me briefly go through the schedule for today. It's a long workshop. We budgeted 3 hours, so feel free if you need to step away, come back later. We will have a break at around 3:15, but otherwise we'll just keep going. Lots of content to cover. As you can see on your screen, there's a schedule. I'm just about to finish welcome remarks, and I will invite next Felipe Soares to talk about communication networks from social media. How do we build them? How do we analyze them? You're going to have a hands-on exercise with this program called Netlytic. This is the program we've been developing for a number of years. And again, you're welcome to follow us step by step, or you just can watch what Felipe will show you and then later on repeat it at home. Then at around 2:30 p.m., and I'll try to be timekeeper for us, because in some cases we have more content than we have time, so we'll have to quickly move on to the next section. So the second part will be around semantic networks. We wanted you to experience all kinds of networks coming from social media, or all kinds of, I should say, representations we can use to understand social media data. And so semantic networks are quite useful to look at the topics that are people discussing, how they're connected, how topics are connected, and why. And so Alessandro will be talking about that issue specifically. And then we'll take a break. After the break, I would be delighted to invite Deena to take over and lead us through hypothesis testing with the exponential random graph models, or ERGM. So that's probably the part that will require the most hands-on involvement on your end, because we are going to use our script. Don't worry, you don't have to understand our script or our programming. We have actually prepared a script for you to follow. You can just execute it line by line, and Deena will walk you through that process and explain each operation, as well as explain how to understand the output and why actually we need to do hypothesis testing with this type of model in the first place. So I hope you can stay throughout the workshop. If, again, for some reason you have to disconnect, we will share the link next week. You can watch it over and over. All right, and without any further delays, Felipe, over to you. I'm going to stop sharing my screen.
Thank you, Anatoliy. I'll start sharing my screen. And if for any reason you are unable to see it, just let me know. Otherwise, I'll just assume it's working. So as Anatoliy mentioned, I'm Felipe. I'm doing some research as a postdoctoral fellow here at the Social Media Lab. And it's great to be with amazing scholars as well in this workshop, and I'm looking forward to learning more about hypothesis testing using social network analysis, as well as semantic networks. And for my part, the idea is to introduce the basics of social network analysis for any attendees that have never done any social network analysis, to be able to do your own analysis, to build your own networks, and most important, to understand what it means, because you probably saw some images like these, very colorful, different groups, clusters, and they are visually very appealing. And that's why many people use this technique to make sense of social media data, especially larger volumes of data. So we probably have already seen some similar image on Twitter, on some news or other platforms as well. And today the idea is that by the end of this workshop, we all will be able to build our own networks, collect our own data, and make sense of it, most importantly. So let's start with the very basics. Today, I will walk you through this initial elements, basic elements of social network analysis, as well as some individual metrics, that is how we look at specific social media users in our case, and their influence, their role in a conversation online, as well as network metrics to make sense of the larger community of all these users and all the entire conversation and discussion on Twitter, on Facebook, on other social media platforms. And finally, some visualization strategies, which will help us to build a network that actually makes sense and help us to explain some of our results, some of the results we identify when we are working with the different metrics. And by the end of this first part of the workshop today, we'll do some hands-on using Analytic to actually apply some of this topics that I'll be discussing in the next 45 minutes. So let's start with the basics, which are nodes and edges. When we talk about nodes, we can think of any type of social actor. Nodes can be people. We could, for example, build a network of attendees here. Who is connected to whom? Who is from the same country? Which attendees study the same topics? Which attendees are part and authors are part of the same track of accepted papers, for example. It could be also like institutions, politicians, which politicians are associated to other politicians. And it could be, of course, as we will explore today, social media users. So here we have three social media users. These are random names. I don't know them. But the point is we have three users. Let's say they are on Twitter, for example. And this is already relevant to know who is there. But what is important is to know, and social network analysis is a method that helps us to understand relationships. It's a relational analysis of some kind of data. So the nodes by themselves don't tell us much. What is relevant is how these nodes are connected. Then we need to look at edges. So we can think of nodes as social actors, specifically social media users, and edges or ties as connections between them. So for example, John and Mary are interacting, or they follow each other, or they reply to each other's message on Facebook or on Twitter. So based on these two elements, we will then be able to increase the number of nodes and edges and build a larger network where we'll be able to identify meaningful relationships and also identify different types of influence of power relationships between all these nodes. So I'll show you some, let's say, offline or non-social media networks, just to give you some ideas of how diverse social network analysis actually is. This is a very interesting work that looked at votes in the US Congress. So we have here, the nodes are politicians. The blue nodes are Democrats, and the red nodes are Republicans. And they are connected, the ties or the edges, connect them when they vote together. So let's say there is a project, two politicians voted yes for this project, then there is a tie between them. And what we can see here is that over time, Democrats and Republicans became more polarized. So back in 1949, of course, you could see the two separate groups, but there was some overlaps. You can see there are edges between the two groups. And when you go to 1997 or even 2011, you see that there are less and less edges between the groups. So this visualization helps us understand how before, like in 1949, there was already some polarization, but there were more overlaps, and now there are less. Another example is many of you are probably familiar with Game of Thrones. And this is a network that basically looks at the different characters from the story and how they are connected together. So let's say Jon Snow and Sam are together in the same scene or in the same book chapter. There is a connection between them. Same thing with Robb and Kathleen. And based on this, we are able to see the different clusters, the different communities of characters and where they interact together. The same thing for the Miserables, for example, and this is a very classic network where you can see all the different characters and which character is interacting with other characters and the groups of characters that are more often interacting between them. Another random example, sports. I love soccer. So this is an example that I really like because when you watch a soccer match or a football match, if there is anyone from Europe and the UK, you see that different players, that they pass the ball, and that's important for them to finally score a goal, for example, because they need to get closer to the other team goal. So this network actually looks at the different players there and how they are passing the ball between them. And based on this, we can see, for example, if I am the coach of a team and I'm gonna play against Liverpool or Manchester City, I might look at this network to identify who is the key player that I have to take care of, like during the match. I cannot allow him to get the ball. For example, who receives or gives the most passes, who is the more horizontal or vertical player, and so on. It could be used as well for basketball or for American football or for any other type of sports. But these are just a few illustrations, so we can have some ideas of how social network analysis work. But now let's focus specifically on social media data and social network analysis of social media interactions, conversations. So we need, of course, to start with the social media. We have different platforms there. We have Twitter, we have Facebook, we have Reddit, Instagram, etc. In these platforms, people interact between themselves. They follow each other, they reply to their comments, they tag each other to show the newest meme or a funny video or a cat video. They retweet each other, they use the same hashtag to promote a social cause or whatever they want to promote. And based on the several different types of interactions, we can create networks. So you can think of a network basically as the bird's eye. When you have a bird flying over a city, the bird is able to see where there is traffic. Or you can also think of a helicopter. You probably saw already some images on the TV broadcast of a helicopter filming where there is traffic in a city, where which roads should you use to avoid traffic, etc. Is basically this idea. But we use this method to have this view from above of all the interactions that are happening on social media. So the idea of having a network, and in particular the visualization of a network, is to help us understand what are the different groups there, what are the different types of interactions, what kind of relationships we can discover between these users, who are the most influential users, and so on. So going back to nodes and edges, I already mentioned that we will be using nodes as social media users and edges as some type of interaction, of connection between these users. But we can have different types of edges because we have several different types of connections as well. So let's start with the most basic one, which is an undirected connection, which is helpful when we build undirected networks. Basically, when we don't have a direction, it doesn't matter who is connecting to whom. It's not a relationship of power, let's say. It doesn't matter, for example, let's think of friendship on Facebook. It doesn't matter if I invite Anatoliy to be my friend on Facebook or if he invited me. What matters at the end is that there is a relationship there. There is a connection between both of us. So when we think about friendship on Facebook, it is undirected because you cannot be friends with someone and someone not being friend with you back. And it is also unweighted or binary. You cannot be friends with another social media user twice. You can only be friends once. So this connection either exists or it doesn't. It's not possible to have two connections between these two friends, these two social media users, because they cannot be friends twice. Okay, so this is the most basic one. Undirected, doesn't matter who connects to whom. What matters is that there is a connection between two social media users, between two different nodes, and binary or unweighted, because the connection either exists or it doesn't. So let's see this example of an ego network, which is basically a network of Facebook friendship. So when we look at this ego node here, this is a social media user, this is a Facebook user, and this user has several friends. So this user is connected to his family here, for example. He's connected to his high school friends in red, for example, and also people from work, from the same university department, or people who have the same advisor. And we can see that there are some overlaps here. For example, some of his college friends apparently, some of his high school friends also went to the same college or know some people from the same college, so they are connected there. But you can see here that there are no different ways the connection either exists or not. Some users are connected to others, some users are not connected to others. For example, here we have some interconnected users, but these users are not connected to this one, for example. So it either exists or not. And it's unweighted, it's binary, it's undirected, because it doesn't matter who invited the other one to be friends on Facebook. It just matters that they are friends on Facebook. So now we are going to a more complex type of connections, of relationships. Now we are going to look at directed networks and also weighted when we have different values. So let's start with directed edges. Think of people following other people on Twitter. I can follow someone, and this someone doesn't have to follow me back. It's different from Facebook, where you are only friends with someone else if you invite and the person accepts it. On Twitter, you might follow someone, but this person doesn't follow you back. So it's directed. It matters who created the connection. It matters if I am following another user or if the other user is following me. So we have different directions there. And if we are also thinking about interactions on Twitter, we can think about weighted edges or edges that have some different values there. Let's think about retweets this time. You can retweet some other user just once, but if this other user retweets you 3 times, there are different values there. There are different weights. So the connection is directed. It matters who retweeted who, and it also has a value, has a weight there, because it matters how many times people retweeted each other or retweeted other users in general. So let's look at this retweet network as an example. Here we have a conversation about a alleged chemical attack happening in Ukraine during the war, the Russian invasion of Ukraine. And in this network, we are trying to understand, to identify who are influential users on Twitter, which users are having their messages retweeted by other users. So we can see, for example, here in this blue group, that we have some Kyiv independent and some journalists, so local media receiving a lot of retweets because they are in Ukraine, they are close to the everything that is happening during the war, so they got a lot of visibility there. They did not retweeted a lot of people, but it matters who is receiving these connections, okay? So we use these different types of nodes and edges of different types of interactions to study several things in networks. But let's start with influence, which is basically to identify users with a lot of visibility or users that connect different users. So this is the individual metrics that we will look at to understand more individual level of influence in networks. So let's start with centralities. Centralities are very useful to help us understand who is the most central, of course, in a network. So they help us to identify different types of influence. Let's look at this network, and this network is undirected and binary. So again, it doesn't matter how many times people are connected together, they just can be either connected or disconnected, and it doesn't matter the direction of this connection. So it's the same connection for both nodes. When we look at degree, we are thinking of how many connections a node has. So you can see that Jill is in red there. And let's say this is a friendship, Facebook friendship network. So we can see that Jill has 6 friends in this network. So she has a lot of friends. She's very popular there. She's very central in terms of degree, in terms of number of connections. So if I need someone popular, if I need someone who is likely influential to their friends, I would go there and talk to Jill. But there are also some other types of influence that can be performed in networks. So we can look at between-us centrality. And when we talk about between-us, we can think about bridges, users or nodes that connect different groups. So we know that Jill has 6 connections. That's a lot, that's very important, but they are all connections from the same group. So if we remove Jill from the network, all people will continue interconnected. Even though we lose someone who is popular, who knows a lot of people, we still have the connections between all the other users. However, if we remove Liz from this network, we actually lose Ellen and Lisa. So we lose part of the network. We lose the connection between these 2 different groups. And that is what gives Liz a higher between-us centrality, because she connects the group on the left to Ellen and Lisa. So let's say I have an open position in my company and I want to hire someone. I could go and talk to Jill and Emma and a few other people there, and it would be relevant because they will talk among themselves. But if I actually want to have more diversity in terms of applications, I would actually go there and talk to Liz because she's able to connect different groups. Okay, so these are different types of influence on social media, on social networks, in any kind of network between social actors. But here we are talking about undirected and binary networks. So here is when we are looking at directed and especially valued or weighted edges. These are subtypes of degree. So degree is basically the number of connections. But when we have directed networks and especially with valued edges, it matters more who is receiving and who is sending the connection, and also how many times this happens. So in degree is the metric that looks at how many connections a node receives. So when we talk about in degree, we're talking about opinion leaders. We are talking about a hub, someone that's influential in the network, a politician, the mainstream media, some influencers, some YouTubers, someone who is famous on TikTok. These people, when they talk online, celebrities especially, they will be able to receive a lot of retweets. They will end up somehow influencing a lot of people there. So you can see here in this example, Justin Trudeau, who is Prime Minister in Canada, every time he tweets, it is likely that he will receive a few thousands of retweets because he's popular. He has a lot of followers. So if we are looking at a communication network where we want to understand who is kind of shaping the public opinion, who is receiving a lot of visibility, we will look at in degree. As this example, this is one example from the Brazilian election in 2018. And it was a very polarized election. So we have two different groups here, one on the left and another one on the right. You see the one on the right is highlighted. And basically what we wanted to understand was about the influence of different types of outlets. So we have in black, the nodes in black are mainstream media outlets. So they are mainstream media from Brazil, very well-known press and TV channels as well, and radio stations, and even some online traditional media. In red, we have some partisan outlets. So these are either far right or far left outlets that are sharing hyper-partisan information, often sharing misinformation as well. And in this network, we used in degree to identify which type of media, which outlets were influencing different groups. So we can see the group on the right, which is highlighted, has a lot of hyperpartisan media in red. This group was also sharing more misinformation because we then used it to analyze the tweets and the messages and the news from these websites. While on the left, and especially more in the center, at the middle of the network, we have more mainstream media. So it helps us looking at in degree to identify which type of outlet is influencing, is shaping the conversation, is receiving a lot of visibility there. On the other hand, when we look at out degree, we are actually looking at very active users, a broadcaster, a political activist, someone who's engaging in some cause, is sharing some hashtag to promote something, or even bots, for example. Here we have one example. It's actually a good bot. It's a bot that was created to share social media politics content. So if we use some keywords to find a network on Twitter that is talking about social media politics or talking about the conference, for example, in some works presented during the Social Media in Society conference, we might find this bot being very active with a lot of out degree, because out degree is the connections you send to some other node. The same when we look at misinformation networks, we might find some political influencers there, political activists, or even automated accounts that are trying to spread misinformation, for example. So this is very useful when we want to look at, let's say, super participants, very active users that are also trying to shape the conversation by selecting who they are sharing, and often sharing like-minded folks on Twitter or other platforms. So let's look at this example, which is also from the Brazilian election in 2018. And this is a conversation about a breaking news that was related to Bolsonaro, who ended up winning the election, and the Purple Group is supporting him But this conversation is about a news piece that involved his ex-wife accusing him of committing several crimes. And while the green group was bigger with more users there and sharing about this news, the purple group was trying to support, was trying to defend Bolsonaro. So when we look at the full network up here, we see that the green group is larger, bigger, more users there, and the purple group is a bit smaller, but it's also relevant. But when we filter the 1% of users of nodes with the highest out degree, that is, the nodes, these Twitter users are retweeting the most people there, we see a different picture. We see that there are some of them in the green group, but most of them are here in the purple group. So that might create a sensation that might simulate that there is a lot of support for Bolsonaro there. And of course, there was a lot of support, but also this was fueled by some bots and by some political activists who were sharing and retweeting every message using a pro-Bolsonaro hashtag. So our degree help us to identify these highly active users in a network. So these are the individual level metrics. When we are looking at influence, we are looking at individual social media users there. But we can also use social network analysis to study communities and larger relationships about the network. So here we are looking at the network level. And one thing that is very interesting, and we often look at when we are studying discussions on social media, is to identify different communities. If the users are all interacting between all of them, or if there are separate clusters, there are users interacting with this group of users, but they are not interacting with this other group of users. And in this case, it's very useful to have different colors, so we can easily identify the different groups there. We can use different metrics. There are new metrics even being developed recently, but a very traditional one and well-known in the field of social network analysis is modularity, which help us to identify these different groups by looking at the interconnection between these users. This is an example of how you can use it to identify, for example, different blogs, a blogosphere during the 2004 election in the US, and to which links, to which outlets they were linking. And you can see that Democrat blogs and Republican blogs were linking mostly like-minded blogs and outlets. This is also useful when you're trying to see some language barriers or geographical location. And this network was about a hashtag that was spreading a conspiracy theory during COVID. And we can see we have one group that is mostly tweeting in English, but we have some other groups, and in particular, a large group tweeting in Portuguese in Brazil. So it also helps us to identify these different groups. And finally, we can use different strategies, and this is the third part of network visualization, to help us make sense of the networks. So we can use different algorithms to visualize it. We can use force atlas, which will separate the 2 or 3 or 4 different groups in the network. They are all force algorithms, so they basically use the force of connections, the number of connections and interconnections between users to create these different visualizations. Or also Fruchtenberg-Heingold, which will push the main nodes, the nodes with the highest degree or betweenness centrality to the middle of the network. But just to sum up, the main advantages of using social network analysis is to be able to visualize and to make sense of a large data set in a concise way. So you can use that to see how people interact with each other the most influential users, the different groups, who is interacting with whom, and so on. And now, to be able to actually see how that works in practice, we will do a hands-on using Netlytic. So to use Netlytic, first you need a Twitter account. And as we already included in the information for the attendees, you need to log into Netlytic and associate your Twitter account there so you can actually collect some data. And also, once you do that, you can request a free upgrade to Tier 2, so you can increase the number of messages you will be able to collect. Before we go directly to Netlytic, I just want to show you the main steps of data collection and analysis. The idea for this workshop is that we can collect the SM Society hashtag to see how the conversation about the conference is going online. And before we do that, I just want to show you on Netlytic, we have several tools there to do text analysis, report on the data set, but we will focus on the network analysis tool. And when we discover a communication network, we have different choices. We have different types of connections, of interactions in the data set. So we have to choose which one we will use. We can look at more direct interactions between users in when a user replies to other users or quote another user, which is a very specific type of retweet when you also add a message. This is helpful if you want to see specific interactions, if you want to see if people are being toxic to each other, if they are harassing or reproducing hate speech, or if they are supporting each other. So this is an example of a reply. We have a message and another user simply go there and reply and provide some additional comments, their opinion about the topic, and so on. And this is an example of a quote where we have an original message and another user just go there and retweet, but also add some content there. So it changes the focus and the message there because there is some additional information. So these are types of more direct communication on Twitter. We can also have retweets, which is a very popular tool on Twitter. And generally, it indicates some type of support or endorsement. It will be useful when we are looking at hashtags, political activism, memes, misinformation, and so on, because we can see what people are trying to make more popular, sharing with their own followers on Twitter. This is, again, one example. We have an original message, and in this case, the user simply retweeted, and it will appear to their followers. And finally, we can look at mentions. This is when you tag another user on Twitter, and it can also indicate some closer connections, some type of connection between users who know each other, but it also can be trying to get attention from influential users or users who might be relevant to support a cause, for example. Again, this is relevant when you're trying to study influencers to see who is being tagged in other people's messages, as well as toxicity, for example, when there is a direct target there. This is one example where a user tags mention several other users to get more attention and more visibility. You can see it here. When we will do this hands-on, we can use all types of edges. But just before I show you how to do it directly on Netlytic, it will show, yes, Anatoliy?
I'm just executing my role of being a timekeeper.
Yes.
So you only have about 15 minutes left before your part ends. So maybe we can actually go back and walk people through the steps of collecting and then selecting the network for visualization purposes.
Yes, so I'll stop sharing and share it again. So we can already go directly to Netlytic and do this entire process using Netlytic. So we can actually collect the data there and analyze. And I'll show you exactly what we had in the slides, which you can also check after the workshop. If you need to if you do your own analysis, you can go back there for all the steps. So now everybody who has a Netlytic account and already associated your Twitter account there, you can access your account and you will probably be able to see any data sets you already have. But right now we're gonna go to new data set. And people who are doing the hands-on, please let me know if there is something you missed or if you need any help or anything like that. Because if that's the case, we can go back and redo some process, but it should be pretty much straightforward. You're going to have here the options of your data collection, and there are several criteria you can use to collect your data. The first thing you need is to give the data set a name. And for today, let's say SNA workshop SM Society. So you can give any name that you want, but this is just to help you to identify this data set after you collect it, and you go back to this data in like a few days from now, a few weeks, or if you use it to for a publication, you can go back and check it there. I'll focus on the keywords only today, just to make it simpler. Let's use the hashtag SM Society, which will allow us to analyze the data set about the conference. There are several other tools that you can use to filter what you want to collect. You can work more on keywords. You can use and or. The Netlytic will give you a lot of information about how to do that. You can also check all the tutorials online that Netlytic provides you, so you can make sure you're doing the search and using the correct keywords there. You can filter by language, by location. You can filter by number of retweets and likes, or you can also look at specific Twitter users as well. And this is a very interesting tool that you can also use when you're doing your data collection to make sure everything's right. You can test the query on Twitter to check if you're collecting the data you actually want to collect. And here, when I do that, I see that we already have some tweets about the workshop, which is pretty nice, and some different tweets about video presentations and so on. So let's go back here. Now that we know we have the correct keywords, and that's what we want to analyze, you can also select only specific types of interactions if that's what you want, only retweets, only replies, depending on your study objectives. But let's keep the collection open, and let's collect every type of interaction. So we don't need for the workshop to add any additional parameter there, and just click import so we can start our data collection. And in your Netlytic, it will probably show a bar while it's collecting it. It's just that my version is a bit different, but you should be able to see the different iterations there, and that you're collecting more and more data about the conference. So I'll go back, but you can stay, and Netlytic will give you some information when the collect is done. Mine is still collecting it, so I will wait a few more seconds, but I would imagine your collection should be going or pretty close to the end. Okay, so mine is done. So now, as I said, there are several tools that you can use there, but let's look at the network analysis, which is step 4. You can test text analysis and all the other parts of it and all the other steps after the workshop if you want to know more about that. And right now we can select all types of connections just to explore a bit the network. You can, if you want to do some specific analysis, you can select only the connection, the edges that will be relevant to your research problem. But right now, let's select all of them and click Analyze, so we can have our analysis and our network. You can see some information here already about how many posters, how many users we have there, and how many ties. You can export this data set if you want to analyze it using Gephi or other softwares, or you can also use Netlytic to visualize the data. It will open a new window where you will be able to see the network. Right here, you can explore it a bit, and I'll show you some elements that were in the slides. So if you use the slide deck after the workshop to analyze your own network, you will be able to see that too. We have here some network properties, which is basically the diameter, the longest connection between two nodes in the network, which is 12. So to go from the one extreme to the other of the network, we would need 12 iterations there, 12 nodes. We can also look at density, which is basically the number of actual connections that we have in the network compared to the number of potential connections. So we basically have a bunch of nodes there. If everybody is interconnected, we would have a density of 1, as this is very unlikely, especially on Twitter and on social media. We usually have lower densities. Reciprocity helps us to understand two-way connections, because this is directed and weighted. We can see when I retweet someone, if this other person retweets me back. And we actually see near 0.3. So we actually have, compared to most online networks, higher reciprocity. So people are actually interacting with each other, not simply one big influencer broadcasting and all the others retweeting or replying, but receiving no response. Centralization helps us to see if we have a few very central nodes or a more distributed network. And finally, modularity helps us to identify how interconnected the different clusters, the different communities are in this network. You can also look for more here when you need to compare your metrics with other data sets from Twitter. I'll actually show you the reciprocity here. It is a bit slow because I'm sharing the screen, but you can see it's like mostly on the higher end here. So it shows that actually our network has a lot of reciprocity there. So people are doing two-way connections there. But now let's go back here. As I said during the presentation, we have some tools to identify clusters. So we can see different clusters here, different communities. We see that generally the network is pretty much interconnected. So everybody is talking to everybody. But we can also change the layout to explore these clusters, the different clusters, and look a bit more of the network visualization as well. And another element of the network visualization is the node size. Right now, we are looking at total degree, which is the sum of in degree and out degree. Remember, because this is a directed network. If we want to see who received the most retweets, who was retweeted the most, we can actually change it to in degree, and we see that it changes a bit. Now, if we want to see who is very engaged in sharing and retweeting other users, we can change it. And we can see who is trying to spread the message about the conference. We can also do things like filtering specific clusters. I'll try to also run another layout so we can explore a bit more different layouts. So this helps us to identify different types of network visualizations. And we can also zoom in to look specifically at some of these users. So we can see who is connected. This is me. I've been retweeting a lot of content about the conference. You have also here the conference Twitter profile, which received a lot of retweets. So if we change it here, you'll see that the conference profile is more influential in terms of receiving retweets, while I was retweeting a lot of people, so I'm right here. And doing those different visualizations, we can also explore which one is the best when we are trying to make sense of this network. So the idea of this initial part of the workshop is not like to give you everything about all the metrics and all the network visualizations and everything about network analysis, but provide you some basic information so that after the workshop and during the workshop as well, you can go there and explore different networks, explore this network a bit more to learn more about it, and do your own data collection and use it for your own research to answer your own research problems and explore some communication networks on social media, here Twitter, but there are several tools that you can also use to explore other platforms and other types of interactions. So to not go over my time too much, that's pretty much it. And I hope now you know the basics of social network analysis and will be able to explore it a bit more, doing your own research and looking for new metrics and exploring different metrics that might be more or less relevant to respond the research questions you have. So now I hand it over to Alessandro, who will be doing some semantic networks to understand
Maybe
a bit
before we jump to
yes,
Alessandro, we have just a couple of minutes for questions. And I see questions
I see questions. No problem, no problem.
So, Felipe, do you want to take that question about interpretation? Essentially, oh, sorry, that's the bots question. But there's a question, Humayun, did I pronounce your name correctly, about being new to the network analysis and it's hard to explain networks sometimes?
Yes, so yeah, that's actually a challenge quite often because in terms of visualization, I show you some algorithms that we can use to make sense of this data. We can use different colors, we can change the size of the nodes, but what actually matters at the end is the metrics, is the more statistical element of the network. So the explanation and how to interpret these results, it depends a lot on your research questions. So if you want to know, who users are the most influential there, who is receiving more retweets, you will look in the grid. If you're trying to identify bots and see who is trying to influence what hashtag is being pushed to go to the trending topics, for example, you might actually look to for degree. So the interpretation is pretty much trying to understand the metrics, the statistical element of it, and using the visualization to help us make it easier for our readers, for other people to understand what we are saying, because it's much more appellative to show you a network and say, oh, here are the different groups and here are the most active accounts, than simply saying that account X or account Y had an in degree of X or whatever. So the visual element is mostly to help us explain our results and make it a concise presentation of it. I
just
see
to
that.
add to
Yes.
Felipe's point about using network visualizations to explain the results, they can also be used to formulate hypotheses and research questions, and we should not underestimate that ability of network visualizations. And this is something Deena will be talking about, how by looking at the network visualization, we can hypothesize about different structures and tendencies, but then Deena will show you how you actually tested it statistically. There are a couple quick questions I can address as well. Pradeep, are you asking about, can an athletic show interactions between suspended or private accounts? We're using publicly available API from Twitter, so there's no public tweets part of the dataset. So if there's a account that is mentioned, that is protected, and you visualizing mentions network, that account will be part of the network, but because the account is protected, no tweets or replies from that account will be visible. So that's the note, caveat here. But at the same time, if you analyze in a live event and you capture data during the event, it's possible that a week, a month later, if you were to recollect the data, those tweets will disappear, those accounts will disappear. And it's an ongoing debate between in the research community and business of curating social media platforms, where Twitter API will say you have to remove the tweets that were deleted. But people in the research community will say, well, we're studying the, let's say, misinformation that often disappear, and we can't just remove it because that's the subject of our study. So I guess the advice is that if you study in that type of dynamics and conversations that are likely to disappear, collect it early rather than wait for too long. And then had a quick question about between centrality. I think Felipe did a great job explaining what it is and why it's valuable, but I do note that Netlytic doesn't include that calculation because it takes too long to calculate, and the infrastructure we put in place is designed for multiple users to use at the same time. So what you can do is to export the network out from Netlytic to external file, Gephi, and that's why one of the tools that's suggested to install today for you was Gephi. And Gephi is one of the popular desktop-based applications where you can then open this network like the one Felipe collected it and visualized, and then calculate betweenness and other metrics there. So thank you for your questions, and keep posting your questions to the chat room. Sometimes it's easier for me, Felipe, Deena, or Alessandro to jump in on your questions and address them directly in the chat room. And now it's time for Alessandro to talk about semantic networks. Over to you.
Okay, thank you all for this opportunity. First of all, thank you to Anatoliy for the invitation. As been said, I'm not an academic profile, okay? Although I've done some publications given the direction to develop a tool that is aimed mainly at the academic world. I teach in pre-university master. In short, I'm an intruder, okay? I'm not a researcher, and I hope to be able to give my contribution, certainly empirical, based on experience gained on the field, let me say. And I'm not clearly a native speaker, so for sure I won't be able to be as effective and energizing as Felipe was, okay? But I'm going to do my best and share my screen, okay? Okay, let me share. Okay, could you confirm me that you are seeing my slides, please? I have only one screen. Okay, thank you very much. So first of all, why is a gentle introduction? Okay, I made a promise. No formulas, no coding. Okay, only a path starting from some basic definition to some practical and empirical cases. So starting from what semantic networks are and why it matters, and some steps through some example, and depending on the time or a practical workshop or a demo from my side. And but let's start. Let me say with the definition. Okay, the definition of semantics, the relationship between words and their significance or meanings has been predominant, let me say, subject in studying linguistic, literature, rhetoric, and more recently in communication computer science. Originating in Greek, the word semantic refers to significance and deals with the relationship between signs, symbols, words, and their meaning. The combination of words we express are also a reflection of the processing in our mind, the meaning of our experience, and it's always processed in relation to the experience of other people. Let's start with a classic definition. At the beginning, semantic networks was mainly a term used by language informed study. During the 70s and the 80s, studies on semantic networks focused on the grammatical and the ontological functions of words and the logic behind their semantic relationship in specific languages. And toward the end of the 20th century, however, the field of semantic network analysis became a research paradigm of its own. And late in 201, Monge and Contractor identified two different research traditions that developed from semantic networks originating in two different research methods and approaches. One tradition focused on the left side on content analysis, and the other on surveys or in-depth interview. So the approach of semantic network analysis that I'm presenting in this workshop, let me say, lies at the intersection between content analysis from one side and social network analysis on the other. In content analysis, the aim is to classify the content into categories, such as topics, sentiment, opinions, and values, for example. Some category could be theory-driven, could pre-exist the analysis, and decided a priori with a top-down approach, or other category could emerge from the bottom as grounded theory, okay? While social network analysis can potentially unveil the power structure and the way communities function. As Felipe said, social network analysis is about influence and communities. And semantic networks is in the middle, is about revealing the structure, the meaning, and also the biases in the text people produce in the specific case online on social media, but not also. Semantic network analysis is a bridge, let me say, between qualitative and quantitative methods. Semantic networks analysis is less expensive and less time-consuming than manual coding, for example, with traditional code books or qualitative approaches. And researchers are not required to manually code the text and conduct intercoding reliability test. And in short, semantic network analysis is less expensive and less time-consuming than manual coding, requires only few resources, and is considered as one of the most straightforward and simple approach for analyzing text, and is less complicated than natural language processing, because is a good point of strength, could be applied to any language without knowing it, okay? And coming back to the basic terminology, we call semantic network a visualization where textual items are connected to each other, basically. So a text or many texts can be hard to summarize or to analyze. And drawing a semantic network highlights what are the most frequent terms, how they relate to each other, and reveal, for example, the different groups of cluster they form. Often, a cluster of terms characterize a topic, so terms that goes together because, for example, is co-present in the same post or in the same part of text. And converting a text into a semantic network helps detecting topics in the text from microtopics to the general themes discussed in the document from an above point of view. So semantic networks are regular networks where nodes are words, for example, USA, the States, or groups of words, for example, United States of America. Relations are usually co-occurrence. Two words are connected if they appear, for example, in the same document or in the same paragraph, in the same sentence, in the same social media post. You decide depending on your research objective. Analysts have faced some issues and have imagined several solutions. So before analyzing and before to able to be analyzed a test, a post, a corpus of tests, there are some issues you could face on. For example, you have to be considered the stop words. The stop words are little terms without informational values. Okay, the most basic, for example, article, pronouns, and so on. The most basic approach is to keep a list of them and remove any word from the text which belong to the list. This practice, I know, is time consuming. It depends on the language, it depends on the grammar. Okay, but exists a lot of lists of stop words you could download from the web, and the term stop words is also used in positioning in positioning website on the web. Okay, so you find a lot of documentation on that, and we are lucky because the software helps on that. Okay, so you haven't to do it manually. Okay, so and stop words is an issue. Another issue is the anagrams. For example, in the previous example, we have talked about United States should be probably a meaningful unit, not just divided in United States, because United States is composed by two terms, so it's called by bigram. Okay, anagram are a group of words, group of terms that could go together and could be analyzed together. You have also to analyze the known phrases. Another approach is go beyond the single word term. For example, United States takes a different approach than anagram. For example, we have to delete all the tests except for groups of words made of nouns and adjective, so ending by a noun. So another issue is consider noun phrases. And finally, you have to consider stemming and lemmatization. So, for example, live, lives, lived in a semantic network is probably useless to distinct from these three types of words. It's useless to have three nodes, one for each of these three forms on the same root. Stemming consists in chopping the end of the words, so that here we would have only one. Lemmatization is the same, but a more subtle way. It takes grammar into account. So, for example, good and better would be reduced to good because there is some basic semantic meaning behind them. But let me say, if you are going to face this issue manually, I know it's time consuming, is difficult, but we are lucky the software could help there are a lot of software that could make text analysis, removing stop words, n-gram, noun phrases, lemmatization for you. And also the software I'm going to show you in next minutes do some of these of this work for your own. And here we have some model. Okay, we have said that in the semantic network we are analyzing co-occurrence, so words that appears together in the same post, for example, talking about social media. So connection between terms are usually co-occurrence. So two terms will be connected if they appear next to each other in some predefined unit of text. So, for example, in the same sentence, in the same paragraph, in the same document, if the corpus is made of several documents, or looking at the social media world, a common method is relate to terms that are present together in the same social media post. And also for this type of network, the weight is important. So an edge between two terms will have, for example, a weight of 1 if these two terms occur in just one unit of text, or a weight of 2 if they occur in 2 units of text, and so on. Some heuristics, we have talked about visualization. Sometimes the visualization part give some direction to the analytical one, but if you are interested in having a good visualization, for example, published on a paper or on web, there is an heuristic that, let me say, 300 words, the 300 more frequent words, or the 300 most connected words, depends on your objective, could provide enough information to allow microtopics of a text to be distinguished. If you include more than 300 words, depends on topology, but generally 300 words is a number, is the upper limit of that I use in visualization. And an heuristic to fit the 300 words in a visualization is, for example, display the most important following a particular metric, for example, degree, or another statistical metric that could be the frequency that a word appear. Let me give you 3 examples, okay, before giving some time for some question and to the workshop part. I've made here 3 examples. This one is the World Co-Presence Network of the Twitter post around the conference hashtag SM Society. I've taken this snapshot in day 1 at the end of the day 1, so yesterday. So here we have only the first day of the conference. There was 321 tweets. Okay, and here each node of the network is a word present in the tweet text. 2 words are connected, so 2 nodes, 2 words are connected if there was a co-occurrence of these 2 words in the same tweet post, and the scene of the link between 2 or more words are proportional to the frequency of the co-occurrence. Here on the right you have some basic statistics, so the word frequency, the word most used in these 321 tweets, and the bigram, the engram. So the word media is co-present with the word social for 60 times. YouTube is present with talks for 20. You could search for this couple also in the visualization, and the more thicker where, for example, media and social, the first one on the right table, where the connection is more thick and more weight. Does it mean that these couple of words are more present than the other? Okay, here I have used SocialVis for extracting data and Gephi for made this visualization. I've used the Fruchtman-Reingold layout, so the more connected nodes are in the middle. Here you could see, for example, social media and conference here in the middle, and the less frequent and the less disconnected nodes are in the periphery. Okay, Fruchtman-Reingold helps to have a complete view of the semantic, so of the meaning of the topics that are in the tweet posts. You could use other algorithms of visualization algorithms such as Force Atlas or IFANU if you are more interested to highlight cluster of things that frequently goes together. If you know Gephi, I have used the modularity class statistics in order to have an idea of the groups, the clusters of words, of terms that goes frequently together. Here you could see different colors, okay? And have here, in this way, you could have a bird view, okay, and have a complete idea of the topics and the terms that is discussed in this first day. During the workshop, I'm going to see you some of this software and going to show you a completed and updated view. The second use case that I'm going to present you is an hashtag co-presence network. So here we have seen a word co-presence network. Here an hashtag co-presence network. You know that on Twitter hashtags are very rich of meaning. Okay, in the first version of Twitter, we have only 300 characters available to write down our text. So included URL, okay, included hidden URL for graphics. Now it's different, but the behavior of Twitter user remain the same, and Twitter people choose their hashtag very careful, choose a few hashtags, and these hashtags are full of meaning. So semantic network analysis could be also applied on that with the same, let me say, with the same rules. Okay, here on the left we have the hashtag co-presence network. And on the right, we have an alternative view. We have an alluvial diagram that you could say is less effective. Okay, is less effective because with an alluvial diagram you could see, let me say, less terms, and you couldn't see and highlight a cluster of co-presence. This network represents 3,000 posts in Italian collected around a specific hashtag. The hashtag is Kaspersky. Kaspersky is one of the most established cybersecurity company, and its product is present in many offices and institutions around the world, including in Italy. As a result of the crisis in Ukraine, many governments are beginning to have doubt about whether its antivirus can be used as a bridgehead for cyber attacks, and about the possibility that the Russian company is no longer able to provide updates. And in Italy, in March, with the Ukrainian decree, the government decided to suspend the use of the Russian antivirus in public administration. So this hashtag quickly became a trending topic, and I have analyzed and published some analysis on my website. And to conclude the first part of the speech, I'm going to propose you an experimental visualization. Here I have collected 2,000, more than 2,000 of posts on Instagram around a specific hashtag. The hashtag is the stay at home, that was used a lot during the lockdown due to the COVID-19 pandemic, was used to spread news, but also to feel part of an isolated community located in their homes. And here I haven't analyzed the text in Instagram post, but I have analyzed the alternate text. The alternate text are the short phrase that used to identify images. You could see alternate text if, for example, an image fails to load and the text description appear in place of the image. This is the alt text that could be added from a user that posts photo on social media, or could be added by the social media itself. Instagram do that, add some alternate text automatically. And alternate text is also used for example, in screen readers to help people with vision impairs. In the graphs, let me say the image description are linked together when are co-present in same image, okay, not in the same post. So from one side we have image, some text that describe the content of the image, and we have linked together when this type of text is co-present in the same image. Here you have to imagine that these posts are written, and these images are taken during lockdown, during quarantine, okay, and people left cluster, okay, take picture of most of all one person, okay, or little group of person, people sitting, people indoor, people sitting on a table, people that take photo of the living room, selfie and so on, and only few take perhaps a photo, outdoor photo taken from window, or perhaps memories of past days before the quarantine. So we have seen three types of semantic network taken from social media. You could relate and analyze word co-presence. You could use rich hashtags, especially on Twitter, rich hashtag co-presence. On Instagram, let me say you have to consider that a lot of Instagram are meaningless. Pick of the day, for example, or Insta Daily, or other hashtag could be noisy. You have to cut off before analyze. And an experimental visualization that connect description of a photo on Instagram. Okay, I'm in time. I don't know if there are some questions before the workshop part. In the workshop part, I'm going to
Hi, Alessandro. There are a couple questions. I can read it for you in the chat room. So the first question, there are actually a few of them. Well, will your slides be available after the workshop? That's one of the questions.
Yes, sure.
Excellent. So we will circulate them after the event with the participants. You also showed and compared a alluvian graph type or chord type diagrams with the semantic networks. And Larissa was asking what tool you use to create those.
Yes, okay, I'm going to share again this one. Yes, I've shown an alternative view, okay. For produce this one, I use a raw graph. I'm going to write down in the chat, but there are lots, okay.
Lots of tools, yes. The other question, thank you. Just trying to go through all the questions quickly. So Kenzo asks about whether inclusion of special characters matters in creating semantic networks. And I think you're going to be showing us Soares soon, and it does have the emoji network. Can you speak to that briefly?
The second part is regarding Soares, and one of the Soares feature. I have a few slides on that. Let me share a moment.
Yeah, and the question is about do we need to care about special characters to include them into the semantic network, and why?
I don't understand what the character in what do you intend with character?
So special characters such as emojis, but again, so you can speak to your question as well. I think you're also asking about other things in the network, right?
Yep.
I don't know if you can use microphone. Go ahead.
Can you hear me now?
Yeah. Yes.
Okay, wonderful. So by special characters, I mean the accents in, for example, non-English languages that we use.
But if the special character change the meaning of the word, is interesting to analyze separately. I don't know if I respond to your question. Other special character, as Anatoliy said, are emoji. You could analyze them in the same way, creating a network of emoji copresence, for example, is one of the Soares features. But I don't know if I responded to your first question regarding characters.
So, for example, do we need to bundle the phrases if this hashtag also uses some accents that are not present in English language?
Perhaps someone could help me to understand the question, because
I think I would answer that you want to preserve those special characters as much as you can, because the meaning can change whether they are there or not. It also depends on the software. Some programs do not support multiple languages, so they might want to standardize, and you lose that meaning.
Okay, now I understand. For example, Soares supports special characters, okay, also written, for example, in Russian or in Japanese, or using diverse, different ISO code, okay, technically speaking. And so what Anatoliy said is right. It depends on software.
Okay, thank you.
And talking about software, thank you, Ken. Good to hear you as well. And I think this is a nice segue to go over to your demo of Soares, which allows you to do some of the steps. And it's related, Yuin to your question, whether the program will automatically remove stop words and do stemming, and that's something perhaps, Alessandro, you can speak to that.
Okay, I see the question. Also, the answer is similar. Okay, because strictly depend on the software you are using. And for example, Soares remove stop words and do some stemming, but doesn't recognize engrams. Okay, so engrams are visible if you download the data and import them in Gephi and have a look to the edges table. So here you could detect the 2 grams, the couple of words. Using the online version, you could see only basic statistics on word frequency and not so much from a semantic point of view. The trick is download the network, importing Gephi, and apply statistics there.
I think we exhausted the questions for this round, but maybe you can switch to the demo part. And in terms of time, we have about 10 minutes, and then we'll have 15 minutes break.
Yeah. Going to share my screen. Okay, please could you confirm me that you are seeing something different from my slides? Okay. Anatoly, could you confirm that you are seeing?
Yeah, maybe you can try to sharing it. I don't know if it's just on my end. It's very small. Yeah, it's very tiny.
Yeah.
But are you seeing the Soares homepage or not?
No, we only see like very tiny bar.
Okay, let me try another time. If don't work, I have some slides that could explain quite the same. Okay, share screen.
Okay, we can see a full browser now. Thank you.
Okay, thank you very much. Okay, Soares works like Netlytic from an authentication and user creation point of view. So reads data from Twitter. Soares use the version 1 Twitter free API, so you could search for 1 week in the past, okay, or collect data in near real time. Once you have created your account and linked your Twitter user in read-only mode, depending on your plan, here now actually we have 3 different types. You have more or less a visualization, a dashboard like that. Basically, in Soares you could search for your own hashtag or words or mention of a particular user, or switch on this type of visualization where there are 6 Twitter trending topics collected each day. Okay, but a step behind here, you could add a search, specify 1 or more keyword chained by Boolean operator here. For example, you could search for a specific hashtag or a combination or hashtag a word chained by Boolean operator. You could use a parentheses and specify other terms and so on. You could search for specific dates. You know, I've just said that the limit is 1 week in the past, and you could filter if you want by language. I've said that the special characters are supported here. You could see all the language, all the ISO code that are supported. Basically, you have 2 types of searches. a search in the past, and this one, the green one, that is a continuous search that in real time continuous collect tweets. Here, for example, I've tracked the event hashtag SM Society, okay, from the beginning. So here we have 664 Twitter posts, of which 400 are retweeted by 161 users. Clicking here, you could access the report detail. Here you have a basic view of the peaks of the conversation in terms of Twitter retweet and the top 10 of the hashtag used in terms of frequency. Here you have the complete list of the tweets around this hashtag. Downloading these in Excel format, you have rich information. For example, latitude, longitude, the device from which tweet are sent, and so on. Here you have some basic statistics around the user involved in the conversation. You have the most active user in terms of tweets sent, okay, and the most influential one in terms of retweet and mention received. And here you have networks. So you have, let me click a little around, so networks loads. Here you have some basic statistics about words in terms of frequency and emoji in terms of frequency of words and emoji used. And here you have networks. Top words network. Here you have 100, the 100 most used word in terms of frequency. The 100 most influential user in terms of in degree. Two users are connected together if they are present in the same tweet, if one mentioned the other, or if one retweeted the other. You have the hashtag co-presence network. Two hashtags are connected together if they are present in the same tweet. And finally, a funny visualization regarding emoji co-presence. Okay, so basically words, emoji, user, and hashtags. Each of these are downloadable in GXF format. That is the native format for Gephi, a well-known desktop-based software for network analysis and visualization. All the network that you have seen in my previous slides are created, collecting data with SocialViz, and then downloading GXF format and refining and analyzing them in Gephi. Okay, I don't know if there is another question, or if I could.
Yeah, we don't have any more questions. Yeah, but we do have a couple more minutes if anybody would like to ask Alessandro.
Yep.
I think people just experimenting with your software to generate questions. So I did find you have options for emoji and hashtag networks, which also can be classified semantic networks because they are visualizing tokens that carry meaning. But in your experience, when you look at word network versus emoji networks versus hashtag networks, did you find any of them are more meaningful in terms of interpreting the discourse you've collected, and why? There's a big difference in your opinion.
Okay, especially analyzing Twitter, that actually is the only social media that SocialViz analyze. So I'm going to respond to another question that just arrived. Okay. Actually support only Twitter, but we are going to release a new version where you could upload your own data if you have textual analysis, textual data, and also could read from Instagram, specifying hashtags. Okay, so we are going to integrate also Instagram. In my experience, especially on Twitter, the hashtag co-presence network are very meaningful because hashtags are selected carefully. Okay, words network need to be exported and analyzed carefully because the word co-presence network, so you have more word than hashtag in a single post, so the connection explode. So also from a computational point of view is a huge work to give a sense to a big network of words. You have to filter on more meaningful words, for example, the most frequent one, the most connected one, and then have a nice analysis. On hashtag is more easy, and emoji analytics makes sense not from a network point of view, but from an emotion detection point of view. For example, mixing them with sentiment analysis. Okay, but the network visualization of emoji, let me say, is curious. Okay, but in my experience, not so useful.
Fair enough. Thank you, Alessandro. Any other questions because before we started the break? I see Deena has a question. If you can enter a collection of tweets for analysis. I think Alessandro mentioned that this is the future feature will be implemented, right?
Yes, it's a future feature. Is also active on the actual release. Okay, is an hidden feature that we could unlock if someone need. Okay, let me say, almost all new features are hidden in the actual version. We have only to unlock them if someone needs. But we are going to launch the beta version in weeks, so the new one is arriving.
Yeah, and Nikki asking related question about other types of data for the analysis. So I think it was already answered as well. In case you're interested and you have data either in CSV format or textual data that you want to represent as communication network. So Netlytic, the software that you've tried for the part 1 of this workshop, there's an import feature from the CSV file or from the Google spreadsheet file. What I'm posting is an online step-by-step tutorial if you want to experiment creating network data from your own data sets. You can do that using other softwares. Yeah. All right. Stay around. Maybe take a cup of coffee, relax, and come back in 15 minutes. We're going to resume, and we'll talk about hypothesis testing using exponential random graph models, and Deena will lead us through that part. So we'll see you in 15 minutes. Alessandro and Felipe, thank you for your presentations for the first half of this workshop. If you can, stay around, but Alessandro, I also know it's getting quite late where you are right now, so it's up to you. Okay, we starting the break. Welcome back, everyone. And again, this is social media network analysis, part 2. Well, actually, it's part 3 because first part was all about communication networks. During this part, Felipe showed you a bunch of examples of different types of communication networks that can be derived from social media data. He also highlighted different components of network visualizations that we would like to focus on when analyzing such data sets. Components such as clusters, why certain nodes are clustered together. Components such as influential nodes, highly connected individuals, why they are highly connected, based on the communication patterns. Then during the part 2, Alessandro introduced us to other type of networks. They are called semantic networks because they don't represent how individuals communicate, but really how meaning is created or co-created by online community members. And he introduced us to software that he's developing with colleagues called Soares. And now we hear the part 3, we're coming back full circle to communication networks. And during this part, we're gonna show you how to run statistical testing with your network data. Because, you know, it's sometimes hard to collect data. It's also sometimes time consuming to produce meaningful network visualizations. But there are many papers out there, let's admit it, that go through these first 2 steps. Collect data, represent it as a network, and then visualize it. And then try to kind of qualitatively interpret and explain what's in the network and why we've seen what we've seen. But quite often, if we're really trying to publish in a high impact journal, it's not enough to just get data, visualize it, and explain what we've seen. So that's where the exponential random graph models can help you with. And so there are lots of handy, well, there's actually one handy R library that can help you run those models. But to use them, we need first to get our data from tools like Anatoliy and other tools associated in that software. Luckily, there are other packages in our studio, in our toolkit that allows us to import files like GraphML files. Those are the common network format that Anatoliy and other softwares can export out. And then you're using those libraries like iGraph or network library in R to import them into the system, into our studio specifically. And once they're in R, we can use other libraries to do the actual analysis. And so Deena will walk you through the analysis today. My job is easy, actually, for this part. My job is just to set you up with the R Studio if you are following us on your computers. And my job is to introduce you to the data set we're going to use, the sample data set we're going to use for this analysis. So let's start with the data set part. Unlike more mainstream kind of platforms like Twitter, Facebook, we decided to use a slightly different social media data set, the one coming from MOOCs, Massive Open Online Course, and specifically one MOOC in particular, MOOC Ads. This MOOC was developed and run by educators, for educators, K-12 educators, essentially teachers, IT support, library support. This class, online class, was designed for them to join and create a peer-to-peer network, share experiences, but also introduce them to different techniques of digital learning so that when they finish this MOOC, they go to their places of education and they will introduce those digital learning tools. And the reason we're using this data set, a couple of reasons. It's well documented. We included the persistent link where you can actually download the whole data set. But you don't have to rush downloading these files just yet from Dataverse repository, because we actually, in the R script we're sharing with you, there's a link you can download it. It's already packaged files, nicely formatted files for this exercise. So don't download them from Dataverse, at least not for this workshop. But in the future, just to situate you, so what we're using for this workshop, this class was repeated twice, I guess, in the springtime and in the fall time. So that's why you have 2 sets of files. And for each class, there are 2 files. One file includes essentially who interacted with whom, so who replied to whom. Similar data, what you can find on Twitter or other platforms. And this file already organized as a network. You don't need to use tools like Anatoliy to represent data as a network. It was already formatted for us as a one representation of the network, which is metrics form. Adjacency matrix, sometimes you heard of that term as well. Essentially, the way you read it is you look at the ID for an individual in this network. It's that data set is anonymized. So the only way to refer to individuals would be by their unique identifier. So let's say we're looking at the row number 13, and there is a user with ID N19. And then when we look at this row, we're looking for cells that includes a value one or more. It means number of interactions that user had with somebody else in this class. And for example, the first one is related to user, and we see in the column N1219. So that's column F. So that's how you would read it. So user N19 replied to user 12/19. And but then if you keep continuing on this row, you also can see that user N19 replied twice to user N19, which is herself or himself. So sometimes people can follow up on their own earlier messages. So it happens. To run an analysis, statistical analysis, to make this data set kind of fair to statistics, more or less, we actually removed two instructors from this metrics in the sample data set we're going to share with you. And this is the reason because if we included two instructors, they would be the most central accounts in the network. And for us, we were more interested looking interactions between peers, so peer network. Was it formed? How it was formed? What are the trends? And the second, we removed group discussions. So this class had some breakout type of asynchronous group discussions. And so if we were to keep those interactions, what would have happened that we only see clusters formed around those group discussions. So what we were interested about more kind of persistent communication that exists before and after the group breakout sessions. So that's why for these two reasons, we excluded these data points from the data set. Second file that came with this data set described each individual actor, online participant in this group, and it essentially provides us useful individual attributes that we can use to test different hypotheses, like homophily effect hypothesis. You can see an example here. Essentially, each row provides a values for different users, where there's some information about their experience, either being a teacher or school administrator, their location information in terms of state. This class, by the way, was offered to the US teachers, but also some international participants joining. For US-based educators, we also know their state location, one of the columns. We also have self-identified gender that participants entered when they completed a survey. All right, so what you want to do to download, before I hand it over to Deena, I would like you to download this R code that we compile that you're going to use. And I don't know, Deena, if you have on your end the link handy.
Oh, this you mean this link? We want me to paste it in the chat?
Yeah, if we can drop that. Okay, Felipe has it. Super, thank you, Felipe.
Yeah.
And I just looking at the chat room. James, thank you for the positive feedback. Thank you. It's unlike talking to Zoom. It's unlike being in the room. You lose all the cues that you see whether people are getting it or whether you need to expand on it. So thank you, James. All right. So what this link is essentially it's RStudio file. It's extension .r, and you need to download it to your computer. If you are following us right now, this file will be opened by your RStudio automatically. Deena also suggested that we mention the alternative to downloading a software like RStudio to your computer. You can actually run it within the browser. There's rstudio.cloud, and there's a free plan. I haven't tried it, but it looks promising. So it's up to you. Sometimes it may not be possible to install it on the computer you use. So rstudio.cloud with free plan may be an option, especially if you're teaching something like that in the future. But regardless how you get into the RStudio, this is how it looks. It's divided in multiple sections. This is this environment that you're going to use to run R script, but it's also a useful environment because it shows you files you can quickly access. It shows you output from your script. It shows you the pictures that you will generate within the same screen. And so the first thing you want to do when you open RStudio is to go to the session menu and set your working directory. So you want to choose the working directory where you downloaded that R script we just gave you. So if it's in your downloads folder, that's fine. So just do the session, set working directory, choose directory, and choose your downloads folder. So I'll give you a second to do that before we continue. So open RStudio, go to sessions, set the working directory, and choose directory to your home folder. Oh, Larry says, thank you. So you're saying you've tried the cloud version? Is that what you're saying in that on that website, and it works well? Yeah, that's great. Okay, I'll give it a try as well later. Because sometimes in computer labs, when you teach RStudio, they might not have R installed, so that could be a good option. And next, once you set the working directory, we'll also want to install libraries that we will need to import files, but also to run the analysis. And so to install files in the RStudio, it's also quite easy. Go to the main menu. Under the tools menu, there's an install packages option. If you're using the Mac version of RStudio, your interface may be slightly different, but what you're looking for is this option, install packages. Alternatively, you can run a command in R code. And in fact, the R code we shared with you, the first line is actually has install.packages, and it will install one of the packages we need, statnet. And it usually will grab and install other packages we need. But if you want to make sure that you got everything, just install one at a time or type. I believe you can do it comma separated in the install packages menu. You type network would be the one package we need, SNA another, ERGM, the main one to run the analysis, and statnet as well. So run the default. And then can I just confirm, in your experience, when you install statnet, will it just grab the other ones?
Yes, yeah. So
Yeah.
if you write install packages statnet, it will bring everything else. I'm not sure if it has network or not. We actually need network a lot. So just install packages statnet would be enough for this script.
Super, yes. And network is the useful package where we want to, let's say, summarize some of the basic attributes of the network you have in your system, calculate some centrality parameters and so on. Okay, so I think my main job is done here. So essentially what we just did, we installed RStudio, or use RStudio Cloud. We got to the environment, we set our working directory, we installed the packages that we need, statnet and network and such. And now you want to open the script that we gave it to you, and it will look something like that in the text editor. What you notice is that we're gonna run the code one line at a time. And oh yes, I forgot to mention, if I can use a pointer here in my presentation, laser pointer. Hopefully you can see the laser pointer right now. Yes, oh, thank you. So when we run commands one at a time, you're gonna click on the button run. So what I'm using the pointer to show you, that's the button you're gonna use to click run, and you have to click it, to go to the next command, you just click it again and again. And some commands will take a few minutes to run, so you might have to wait until the previous command is finished to go to the next one. And what you also see that some commands, they're so long, what we did, we split it in multiple, it shows up as on multiple lines. So for example, the first four, it's kind of easily to understand. We'll load the libraries we just installed. So library network is the command to load it, but the other ones, it's to load the actual data. And the URLs you can see, it's actually were from the Social Media Labs website, where we just prepared in advance the two files, the metrics and the node attribute data for you. So this way you don't have to download it to your computer and don't have to deal with this. All right. So hopefully you managed to keep up. And now over to Deena.
Thank you, Anatoliy. So I'm going also to share through my slides. Okay, so this is what I'm doing stuff. Okay, so let me know if you can see my screen share.
Yeah, I can see it. How about everybody else? Yeah, all good.
Okay, great. Thank you. Okay, so hello everyone. I feel a bit bad now that I'm going to share with you like models and equations and stuff and stats, and some maybe it's evening for some people in the other end of the world, but I'll try my best to make it as easy and simple as I can. Okay, so you know now about the data set from Anatoliy. He explained what the data set is about, and I hope that the R is working with you and that you are able to load the files. So we have two files here. The first one, the edges actually command is bringing the edges network. So basically who replies to whom or who interacts with whom in this MOOC. And the second one is, this is where you load your nodes. So that's basically the attribute file that Anatoliy showed you before, where we had some information about the experience, the location of the participants in this MOOC. And then this command, which is actually a long command, 4 lines command, this is bringing together the attributes file and the edges file to create the network. We didn't start ergon yet. We didn't start any stats yet. We're just creating the network. And on this network, we are going to do the model and the stats later. So this is using the network. All of this is using the network package in R, in which actually you are going to create the network. Once you have the network created, it's called now net. And from there, we can run many other stuff on the network to see it, to visualize it, and we can also run centralities and all of that. Okay, so this summary of network, it's basically going to tell you what the network is about. So we know that the network has 232 nodes, that's 232 participants, and we have the number of edges, 812 edges, basically 812 interactions between these participants, be it reply, I believe it would be mostly replies. And we also have the density of the network, which is the number of all possible edges that could occur, the number of edges that are in this network divided by all possible edges that could occur in the networks. Okay, so it also gives us some of the attributes. It tells us information about the different attributes we have, the countries they come from, how many people, like, for example, here we have 217 from the US, and other places around the world. It's showing us just the 10 most common values. Okay, so all of this is just the output, how to understand the output of summary of network. Now, if you want to visualize this network and see how it looks like, something you can do in Gephi as well. So, and something that Felipe showed us at the beginning with Netlytic. So that's the command in R, plot net. Net is the name of the network, as you can assume now, okay? So now here we have this network. It shows like a nice hairball with all, every node is a participant and the edges between them is who reply to whom. And we can see that this is a directed network now. So for example, this person here replied to this one, but not vice versa. So that's why we have a directed network. So I'm going also to walk you through the code and explain the outputs and results. And please feel free to write in the chat. Anatoliy will tell me about the chat if you think I'm going fast and you're stuck in your code. And the other thing that I always advise, if you feel really away and you're behind, you don't have to worry about this. The R code will work. Just do focus on understanding the output and what it means, and you can follow on the slides, and then we'll go back to the R code later.
Yeah. In fact, you know, there are no comments just yet, but I'm wondering, Zoom allows us to share more than one screen, and I have RStudio in front of me, and I'm following your steps in case people have questions. So what I'm gonna try just quickly, if it works, to share my screen in addition to yours.
That would be
so
great.
Fingers crossed. Let's see if it works. And so I think we have to ask our participants what do they see on their side. Do you see both of our screens shared?
No.
Sorry to jump in. You need to click on view options on top of Zoom screen, and you can select which of the shared screens you will look at. So I can see, you can choose only one of the two screens, but we cannot see both at the same time apart.
Okay, just didn't want to make more things complicated, but if it works, yeah, and I see people figuring out the view option. I suggest keeping Deena's screen on because she's going through the main slides, but I'm repeating what she's presenting so you can actually see what you should see on your side.
Yeah, and you'll also have the code in the presentation I'm giving, so it will also show you the code. It's written both the code and the output as well. Okay, so it's good that we don't have any comments saying that people are behind in terms of running the code, so that means it's working well for them. Okay, so that's the visualization of the network, just a pure visualization without any aesthetics that will come later, like in terms of coloring based on gender and all this stuff. Now we are going to introduce the ERGM, or exponential random graph models, and why do we use them? So basically, we can have some insights out of the visualization, or as Anatoliy said before, that we can build some hypotheses based on the visualization. If we can look at the visualization and see some females connecting to each other more than males, for example, we can say, oh, maybe I need to test whether there is really a significant relationship between whether people connect to each other based on gender or not. And these types of questions is where ERGM comes in. So basically, ERGM is a type of statistical network modeling in which you use it for network analysis, so exponential random graph models. The main difference, for those of you who have background from statistics, the main difference between ERGM and other statistical models is that the ERGMs relax the fact or the assumption that the nodes should be independent from each other. Because by default, network nodes are dependent on each other, like someone replies to someone else. So there is some sort of connection or relationship between the nodes. So the main interesting point about ERGM, and you cannot use other statistical models, is that basically there is this some sort of assumption that there is a dependence between the nodes. The main question we ask about ERGM is why a tie exists. So my dependent variable in all models will be of ERGM models will be why there is a certain tie between node A and node B. This is the statistical question I want to test here in all ERGM models, okay? And the nice thing about ERGM models is that it is based on logistic regression models, so you can interpret them the same way you would interpret logistic regression, which is an easy thing to do in stats in general. Okay, so let's say, for example, why do I use ERGM? Let's say I colored the network now. That this is the same network we have from the MOOC. So let's say I colored by gender. So in this one, here we have the red is the females and blue is for males. And I want to ask the question whether birds of the same feather flock together or not. So basically, do females tend to reply more to females than they do to males, or is there more interaction between males? Is there basically interaction based on gender or not? So this is a question where I would use ERGM for. Another question would be, for example, something that is more complex would be, okay, is the network structure itself is what makes me determine whether there is a tie between two nodes or not? So basically, I'm here taking this statistical lens and seeing the connections between the nodes and trying to understand, is the structure that is already there, embedded in the network, the reason that is making my ties look this way. For example, do I have some sort of closure, like 3 people connecting to each other? This is called triangles in the network structure. So do I have many of this sort of structure, 3 nodes connected together? And let's call it Deena for now, okay, because this is part of the algorithm. Or for example, do I want to test popularity? And this is a lot on social media. So you know that some of the influencers, they have a lot of ties coming to them, right? So the very primitive form or structure of a popular node will be something like this one, where this person, I'm not sure if you see my mouse or not, but the node
see the mouse, yes.
Okay, great. So the node that is in the center here would be, let's assume it's the popular node, and there will be directed edges coming from all other nodes to them. I can have more. I can have, this is called a 2-star, but I can have 3-star, 4-star if there are more people coming to this node or mentioning this node or tweeting this node. So this is a measure of popularity, right? If I have many of this structure in the network, that means that this node here is a popular node, okay? Or that if this node is having a lot of ties around it, that's because it is a popular node by itself. Like there is an embedded structure in the network that says that this is a popular node. So that's basically what Ergem is telling me. Okay. So these are different types of questions that I can ask based on Ergem. So the first and very basic one that we put in every model is and we call it even like later the intercept of the model would be whether there is some sort of tendency towards friendship. And here I'm basically testing the number of edges, okay? And we'll call it the number L, that's number of edges. So basically the question is, is there a tendency towards friendship in this network? Because, you know, sometimes there is no tendency towards friendship, and this happens in social media a lot, like just networks are sparse networks. You don't have many connections between them. So the type of network I have here is a sparse network, no tendency towards connection. So the network connection will be how many more or less edges than observed by chance. What does this mean, network connection now? I want to test, and this is my most important question that I test in Ergem. I want to test whether the relationship I'm going to see here in terms of formation of ties, does it happen by chance, or it happens because there is real tendency in the network towards formation of ties? Does it happen because I flipped a coin and I have many ties connecting to each other based on chance? Or is there really some people intentionally tend to go and do form some relationships with others? Then there will be more tendency towards friendship. And here I'm testing a network property, which is density. Let's take another example let's say, take the one about popularity, for example, that we were talking about. So the question would be, are there central people in the network that are popular? I want to test whether this is happening, or the fact that I observed some of these structures in the network is just happening by chance. There's no really clear thing that would tell me, or clear evidence that would tell me that there are some people that are popular in this network. Okay, so this is here I'm mentioning, or I'm testing the local property of the network in centralization. And if you take an advanced social network analysis class, you will learn about many more, like these are just some examples, many more of network properties that you can test through using Ergem models. Another example that we use here in this workshop is homophily. So do males tend to befriend males and females befriend females? Basically is like birds of the same feather flock together, like people connect to each other based on gender. So I want to know if I observe some of these relationships between male and male or female and female, is this happening by chance? Or is there really a clear evidence in this network that this is happening more than it could be by chance? So there is more tendency to homophily. So this is basically what ergon can tell us, we can have many things. We can have put many factors, I mean, in the model. So same, you can test gender, homophily. We can test a structure of the network. So for example, we are going to test reciprocity. This is a structure, embedded structure of the network. We call it endogenous factors. That's basically if I send you a message, you tend to reply back to me. I can test this thing. I can also test another network effect. So let's say, for example, let's take the example that Alessandro showed us, like words connecting to each other. This is a network, right? We have a network of words. We can take this network and put it in the model and test whether people tend to reply to each other if they share words with each other. And that can tell me definitely can answer some of the social questions that I do have about these networks. Let's say I know about attributes of certain people and females. Do females tend to use some words together more than males do use? Maybe males would use other words together, and so on. All these are questions I can understand using ergon. Okay, so for going back to our example today from the MOOC, we want to test many things related to the network. So the dependent variable will always be the formation of a tie or not. And the independent variables are now going to be, I'm going to test whether people of the same gender, they connect to each other or not, whether people of the same experience, they tend to connect to each other from same location or a region, reciprocity, and other things that I can also put in the model as I told you. Okay, so let's start with the first model, the model I told you, the very basic model, the one that will only include the intercept, which is the edges. So this is the way you write the ergon model in R. Here now you can go back to your R and see and run this code. So that's after each model we create. We are going to do many models today. So from model 0 to model 5, hopefully you can do most of them. And after each one, we can write summary of this model to try to understand what this model is telling us. Okay, so the summary of the first model edges is always, and this is always you're going to see, it's going to, you need to look at two things. This is the theta of the model, the one thing that you can use for to interpret the network. And the other one is the p-value, whether it's significant or not. And here I'm talking like same like regular stats. Like the theta is going to be interpreted the same way you do an interpretation of a logistic regression. That's basically trying to see the probability of formation of a tie, and the significant, whether this is happening by chance or not. And if it's less, the assumption is that if it's less than 0.05, p is going to be a significant, there is a significant relationship, which means it's not happening only by chance. Okay. So another thing that is going, we are going to test whether this is a good model or not, and through different things. We are going to test it through the AIC and the BIC, and we are going to also use some other techniques that are used specifically for ergon to test whether it's happening or not. The way ergon works is that it creates simulations. So let's say I have an observed network, the network that you already saw here. This is the observed network. And it's going to create, let's say I choose 1,000 simulations, okay? So it's going to create 1,000 of the network, okay? And it's going to try to find a model that will make this observed network fit the best in the middle of these 1,000 simulations, okay? So I want the observed network to be between the 1,000 simulations, so that way I'm actually bringing the model that will bring me closest to the observed model. This is what I'm trying to say. And you'll understand shortly why I'm saying this closest thing, because it's never exactly the same model of the simulated networks, okay? So that's the BIC. And now if I want to understand or interpret the theta, which is my statistic here, This is the same way we do it in logistic regression, which is the exponential of this number divided by 1 plus exponential of this number. It gives you the probability. So this is a command in R, which is the Plogus command, gives you the 0.015. Okay, that's the same way. So there is a probability of 1.5% that these two people would connect to each other, or two people would connect to each other in this network. And guess what? The probability here, if we don't have any other variables in the network, is going to be exactly the same as the density of the network, which we saw before here when we were showing here. Remember the density? The density was 0.015, right? So the probability of formation of a tie in a network or in a model that only has the edges is basically the density of the network, because I'm just asking what is the probability of the formation of a tie. This is the density of the network, number of ties divided by a number of all possible ties. Okay, so far so good. Let's now actually try to understand how does this model, is this model a good model or bad model? I cannot tell now because I don't have other models to compare with. But let's actually keep these values in mind, the AC and the BIC. So this is one way we are going to use now to check whether this model is a good model or not. I cannot do now. You usually want to see an AIC or a BIC that are small. The smaller, the better. The other way is going to be through visualizations. So I'm going to plot the network that is based on my observed network. And I'm going to plot a network that is based on this model. I simulate any network from this model and plot it and see whether they look like each other or not, because I want some model that will bring me closer to my observed network. So here, this command that you see here, this is just for plotting the network in R using the gender as a color. Okay, so the females are in red, and we can see obviously that there are more females than males in this network. Okay, females are in red and males are in blue. One other thing that I can do through R is just seeing how many ties can exist between people based on gender. So this is creating the table that is going to show me that females connecting to females, there are 427 ties, and males to males, there are 665 ties. And then we have also female to male or male to female. From this table, I can see that I have more connections between females than there are to each other than there are between females to males. And this is actually happening in the males less. So there is some sort of homophily among females, but not necessarily homophily among males. I could not really tell this from the visualization. Visualization is telling me more females than males. But this table can tell me that there is some sort of homophily, or people like each other connect together. This is the word homophily. Between females more than there is between males. Like male to female is 116, but male to male is just 65, okay? So the table is not really telling me. What will tell me is the ergon model, but it's just a way to try to understand how the ties are created in this network, okay? So here is the model where I added, so the first model was just net and edges. The second model, we added the node match. And node match here is when we want to test homophily, okay? The term for it is node match in R. And here you enter the name of the attribute you want to test. So if you want to test based on gender, you enter gender and you make sure that this is the same attribute written in your file. And if you want to test experience, you test experience, you just write experience and so on, okay? And you want to test whether the diff equal true is basically to test whether the networks like female connects to female or male connects to male or not, okay? And then again, after I run the model, to see the result, I just write summary of model 1. So this is our second model today, which is model 1. Okay. So here we can see that the edges, we already understood it. We can see that there is a significant relationship based on female connection to female, but this is not happening in male connecting to male, which we expected because we already saw it from the table before, that there could be a relationship between female to female more than it exists between female to male or between male to male, okay? So I can say now, okay, one of the things that is happening more than by chance, that females tend to connect to more females in this smoke. Females send replies to more females than they do send to males, okay? So this is the second thing that I tested through the model here. And the model is basically showing you again an AIC value and a BIC value. So let's see now whether my new values are better or my new model is better than the first model or not, okay? So, yeah, one other thing before looking at the difference, if I want to interpret the coefficient and I want basically to see the tendency or the probability of a formation of a tie between two females, I take the coefficient of the first edges. Edges is my intercept. I always take it with me, okay? Plus the coefficient of the second of the line that I want to test. So between two females, this is going to be the probability of the formation of a tie between two females, which is 0.018, okay? So there is 1.8% chance that two females would send a tie to each other more than they send it to a male, okay? Okay, now let's compare. Now I have a null model that was created at the beginning, and I can compare my new model to it. And it looks like my new model is performing better, which I expected because we can see a lower AIC than, and BIC is almost the same. So maybe my new model is performing better than the other one. Another way to test it is basically through looking at the table that I created. So what I can do is I can simulate one network based on this model, okay? And this is I'll call it model 0.sim simulated. And I can create the table from this model, the table of a network that was created by this model, and then compare it to the second model, which is the model number 1, and compare them to observe. This is my observed network. This is the network I really want to always look like, and see which one is closer to these values. So here you can see that the 355 and 77 are not necessarily closer than the 416 and 69, closer to these two values, right? So this model is definitely closer to my observed network than any other model, or than the other model that was created before. Okay, I hope everything is good so far. Okay, a third way to test whether and here I'm doing it because it's a small network. Okay, we're doing it here because it's small network. You don't do this with big network with social media. The way we are going to test models with big network with social media is coming in the next slide. But all these just to show you for the sake of this workshop, how the models compare to the observed network. So this is my observed network in terms of visualization. Yes, Anatoliy, you have a question?
Oh, just wondering if we can stop just for a second, and explain syntax of the R.
Oh yeah.
You know, okay. When you run an existing code, you don't necessarily need to understand, individual components of the lines, but because this one is quite scary, can we just point out certain things that people would change if they want to fine-tune the visualization? Thank you, Deena.
Sure. Okay, so now here, this one is giving is just plotting. So that's for the plotting of the visualization. And here you enter the name of the network that you want to plot. So this is the network you created. And then how to color it, you say that the color of the vertex is going to be one or two things, okay? Either blue or red, okay? So you just put them here. You wanted blue if the first condition is not satisfied. So basically here, the condition is satisfied. You want to test first whether gender equal to female, okay? If gender is equal to female, you don't want the output of this equation to be 1. You want it to be 1 plus something, okay? So if gender is equal to female, all this line between the brackets is going to be 1. So the result of this equation would be 1 plus 1, which is 2, which basically in R, it's going to see, okay, that's the color of this vertex is going to be the second term here, which is the red. Okay, so it's going to give you a color of the node, which is red. If this condition is not satisfied, meaning that the gender is a male, this is going to be 0. All this term is going to be 0. 1 plus 0 is 1, and is going to give you the color blue. So that's basically what this complex code is telling us. Okay, and this is how you want to. So basically for you, if you want to change based on other things, female is going to be, let's say, experience, high school, or whatever, and you can color based on different things. Okay, and you can also pick different colors in R for sure. Okay, so the now looking at the network, which one looks more? This is the one created from or simulated from the first model, and this is the one simulated from the second model that includes gender, and this is my observed network. And it's clear that this one definitely is not at all like the observed network, but it is closer to the observed network than this one that doesn't have it, because I can start seeing some actually nodes that are more on the periphery looking like this node. Okay, so let's continue and check now. Here is basically, if you are going to use social network, social media data, these are the ways to check your models. Okay, so the goodness of fit. First, you are going to check the goodness of fit. This is a command in R where you check the goodness of fit of model 1. That's the model that has the gender. And what I want to see is basically, okay, the dark line here, this one is my observed network. And anything that, and let's look at here, it's clearer. Anything between these two lines with the box plots, the small box plots, these are the number of simulated networks that I created. Okay, I told you that Ergon, the way it runs, it creates many simulated networks, and it will always try or optimize the model by trying to bring the observed network or the simulated networks closer to the observed. So what I want to see is that this dark line here would actually follow the same pattern like these ones, okay, or the simulated ones. Clearly here, it doesn't follow. Follow in terms of what? I want to check some of the factors that are in the network that I did not put in the model. So for example, in the model, I put gender. So here, I'm not going to choose gender to check or not, because I already put gender in my model. I want to choose other factors that are characteristics of the network, and I want to see whether the characteristics of the model, the simulated networks that I had in this model are similar to the characteristic of the model. I already have density, so I'm not going to choose density. Another characteristic of the networks is the minimum geodesic distance. That's basically the distance, the minimum distance that can exist for one node to reach to another node. You remember Felipe talked about the diameter, which is the biggest distance between two nodes. That's exactly the opposite. The smallest distance between two nodes, which is the minimum geodesic distance. So I want to see whether my networks or my model that is based on these simulated networks, it is actually closer to the observed network or not. Clearly it's not, because I don't have this line following the different networks that are there, okay? So let's have another, so here is showing you edgewise shared partners. This is another characteristics of networks that is basically testing the triangles or the clustering in the network, okay? So this is here, because of this part here, the observed line, the dark line is not following exactly the others or closely to the others. That's why I don't have a good model. It's following here, it's following in here, but in the middle, it's not really following it. So that's why you can say, or you can interpret that I don't have a good model based on just gender. Okay, so we can actually, I just want to check based on the time, just to check myself.
Yes, in terms of time, we started just a little bit late after the break. So I think we have about 10 more minutes. And if people would like to stay a little bit longer for questions, you're welcome to do so. So we, just to highlight something that you might have missed. So we showed you, referenced the significance level for individual variables. We also talked about AIC and BIC criteria that shows us the direction, whether by adding additional variables, we're actually improving the model. And in this case, as Deena showed, this particular model one is improving because both AIC and BIC decreasing, but the goodness of fit test still shows us that we need to keep improving it because it's not good enough to publish it.
Yep.
Okay, over to you, Deena.
Thank you. Okay, so these are still the rest of the charts that in R you are going to see all these charts together when you run goodness of fit. So these are the in degree in terms of in degree of the network, which is the number of ties that are coming to the nodes. It's not also following, and out degree. So that model is not a good model. Okay, so let's try to see another type of model. And in this one, I'm going to add another variable. This is the third model I'll create. The variable that I'm going to add, you see that these two are the same that we used before. I'm going to add here node cov, which is experience. Basically, I'm adding an attribute. Okay, this is when you want. This is not node match, because node match is seeing whether these two people similar on a certain attribute, whether they connect to each other or not. This is node match gender. But node cov experience, that's basically asking the question whether people from university level are receiving more ties than people from a high school level, for example. Okay, so that's why I use node cov and not node match. I'm not here asking whether people from high school connect to people from high school or not. I'm asking whether those that are having a higher level or of experience, for example, are more mentioned than those who are having a lower level of experience. Okay, so here, if we run this code, you will get another actually significant relationship or a significant variable that's based on experience. And we are going to see the AIC and BIC now. But basically, it's telling me that there is a chance of tie increasing with each incremental increase in students' experience. So if you go to a university, there is a more probability of people sending you a tie because they probably ask you for advice or something. And this is basically, if you want to see exactly the definition or the interpretation of the theta here, or the probability of a formation of a tie, this is, you are going to get it from the same Plogus example that we did before. Okay, I'm not going to go over the Plogus now, just for the sake of time. But to see now, the model with experience is having a lower AIC and a lower BIC than the model with gender only. So definitely this model is a better model. And if you want to actually, so that's the another model. You can also draw, if you want, you can draw plot using the same command. You can plot the model with experience and see whether it shows a tie that is closer or not. You can also create the table and see whether the table is closer to the observed network or not. I mean, you can repeat the same commands you have in R if you want to play with the code with these same variables. Just here showing you some of the things that you can do. Okay. Now let's have another model now when we have so we already have a gender, we have the experience. Now we want to create a node match region now, and you can definitely guess that node match here is what is asking what? Node match here is basically asking whether two people from the same region, whether they tend to connect to each other more than they connect to people from other regions. Okay, so that's homophily based on region. That's why the term node match. Okay. So I run it and I can see here many things. Why didn't I get this only with the model with the gender? Because gender, I only had male and female. And before, when I created the other time when I created the model with gender, I had male and female. Why do I only see female here? Because I found that female was the only one that was significant. So why keep it in the model and having many lines? One thing I can do in R is adding keep equal 1, C of 1, okay? So that's basically going to give me the only factor in the different factors of, or different levels of the gender attribute, the factor that is significant or the level that is significant. So I had two levels, I had male and I had female. The one that was significant, male is 0, this is for R, and female is 1. So the one that was significant is female, which is 1. So that's why I do C is equal to 1. Okay, and you see again, we are going to do the same thing now for the region. But just running region without keep, this gives me all of the regions, okay? And I can see that there is a significant homophily between international students, and there is a significant where the stars are, and there is a significant homophily between people from the southern region. Other relationships are not significant. Okay. So let's see now what we can do or how we can compare the models now that I get from the southern or international regions. Now I added keep 1 and 4. 1 was for international students and 4 was for the southern region. That's why if you run the model again, you will only see these two instead of seeing all the lines that do not make significance. I can only see 2 lines. Okay. So now let's come to the important stuff now, comparing the validity of this model or whether this model is or robustness of this model, whether it's a good model or not. So the first one is AIC and DIC. Okay. So now I'm having significantly a better AIC for sure, because this is less than the model before. This is the model with all of them plus region. And the BIC is almost the same. So this is a better model for me. And if you want to check it with plotting, you can start seeing that the model that is gender plus experience plus region is coming more and more closer to the original observed network than the null model is. Okay. Now I'm going to, and you can also through running the goodness of fit of the model 3, you can see that it is probably going to follow the pattern, but not necessarily. This is a lot of exercise in ergom. If you want to see a model that has a good goodness of fit, that's basically, you can try many models. Sometimes it does not converge, meaning it tells you that line in R in red, the model does not converge. You need to try another model that will converge and gives you an output. So I'm just giving you this not to be frustrated. This is everyone working with ergom. You'll see this. You will not really reach a good model right away. Okay. So this is, I'm going to actually go for the same. This is exactly the same, showing you that the observed network does not follow, or the simulated networks actually do not follow the observed network. So this is not a good model. Let's run now a model. I'll skip to model 5 for the sake of time, because model 5 will also have model 4. As you can understand now, we're adding more and more things. So I'm going to skip to model 5 because this is going, and I'm going to show you the MC diagnostics. Okay, so model 5 now. In model 5, I already have the gender, I have the experience, I have the region, and I added 2 more things. Mutual is one that was added in model 4. And the GWI degree is another one that we just added now. What is mutual? Mutual is a term in R to check whether 2 people tend to communicate with each other or not. If I send you a tie, you tend to reply back to me or not. So this is just by using mutual. I'm not here using anything, if you notice, I'm not using anything related to the attributes of the nodes, because this is not a characteristic of the attributes or the nodes. This is now an endogenous characteristic of the network, something that is embedded in the network, okay? So you want to actually add anything related to attributes here, okay? And same for this one. The GW in degree is basically the geometrically weighted degree. And you'll use this a lot in social media. In social media, you know that there is always tendency for influencers to have more in degree to them, like influencers will be retweeted more, they'll be replied more. So in order to overcome this challenge, because you'll always have tendency to ties to influencers. So in order to overcome this challenge is the GW I degree or the GW degree, if it's not a I degree or O degree, is in degree or out degree. This is with directed network. But if you just have undirected network, you'll have a term called GW degree. So this one actually was created because it's going actually to add more weight to nodes with less incoming ties to them. So it will make up for the problem of the influence. Okay, so this is why the GW I degree is added to the network, and use it a lot with social media, because in social media, you always have tendency for people to retweet influencers or to reply to influencers or whatever. So in order to overcome this challenge, you are going to control for the fact that some people are influencers or not. That's basically what you're doing here, okay? If you, because the term was created penalizing the influencers, basically putting less weight on the influencers. If you get a negative term, that means that there is a tendency in the network more than it is expected by chance that people are going to mention influencers. It's a bit tricky here that because it's negative, but the fact that it is negative means that there is more tendency for people to receive ties, for some people to receive ties, which are the influencers, would be, I assume, in the network of social media, for example, or here it could be we remove the instructors, basically. Yes, Anatoliy, time. No?
And then just because we just added time, and I see some people have to run. Let's just finish. We have just couple slides, and maybe Deena, you can zip through some of them. But sure. Before you do that, maybe something useful to point out. The region people from South now no longer statistically significantly more likely to talk to each other. Can you speak to that interesting phenomenon? So after we added structural elements, mutual and the geometrically weighted in degree, suddenly the other element that we thought is significant is no more. Can we speak to that a little?
Sure. So basically this happens even in regular stats. Sometimes if you don't control for certain variables, you will find a relationship and you'll be happy, oh, there is a relationship, people from the southern region are connecting to other people from the southern region. But now if you are controlling and saying, oh no, I'm going to control whether there are mutual relationships or not, and I'm going to control for the existence of relationship or not. So if you add these as control variables in the network, now the effect of people from the southern region connecting to each other like faded away when you controlled for other things, because maybe it was there because you did not control for mutual relationship. It was there because you just thought it is there, but the reason that was making it is mutual relationship and not necessarily people from the southern region to each other. When you control for this variable, which is mutual, that is actually going to give you the relationship that the relationship between people from the southern region is not really a significant one. People from the international region or international people in general, whether you control for this or you do not control, there is a relationship between them, which means that there is actually indeed a true relationship that people from international people tend to connect more to other people who are international, and even after controlling for other variables that are mutual or in degree or influencers, controlling for embedded structures in the network is very important, because this tells you now about the real importance of the attributes that you are interested in the network. Usually you are interested in the attributes of the individuals. You cannot just run the attributes of the individuals without controlling for embedded structures of the network. This you can do in regular stats. And the beauty of ERGM is that it is giving you the possibility of adding embedded structures of the network as control variables. You cannot do this with regular stats. Okay. Now I'm going to go quickly through the goodness of fit now. Okay, yeah. One of the things to check the goodness of fit of a certain model is to, and this is actually looking at the variables that I already put in the network or in the model, not the variables that are out from outside. So the GOF command is going to look at variables outside from my model, at variables that I didn't put in the model. The MCMC.diagnostic, this one is going to look at the goodness of fit of the variables that I used in the model. So I use the in degree, and you'll see other variables. What I want to see when you see these structures that are coming in the output, I always want to see a balanced graph here, and 0 is in the middle, or basically among the mean. 0 is going to be my observed network, and this is why I want to see it balanced. So I want to see my observed network basically in the middle of all the other simulated networks that I have. And I also, in this one, in this graph, I don't want to see things that are away from the graph. I want to see something that is running smoothly, like the heartbeat of the person, probably around the middle of this line. Okay. So this is also another way to try to see the goodness of fit. If you have a poor fit, if you do all of this and add all these variables, and you have a poor fit still of the model, what you can do is use these commands. Here is increasing the sample size. So maybe because your sample size is small, you did not get to a model that makes your observed model actually, or your observed network in the middle of the others. So if you increase the sample size, instead of 5,000, you can do 10,000, for example. If you increase the sample size, that is going to let your model be probably a better fit. And also the different intervals and burn-in, I'm not going to go into details, but these are actually things that you can, parameters that you can also play with in order to change the, and make your model converge. If it doesn't converge, these are tips, if the model doesn't converge. So you can change these two variables, and you can also increase the sample size. Seed is something that is interesting for you if you want to duplicate your results. Always start, this is, it could be any number, 351, any number. But if you want to duplicate it, always put a seed, because that is going to actually give you the same model again and again. Okay, so what I'm going to finish here with, this is the model that doesn't happen in reality a lot, where you have a real goodness of fit, and you have a real model that is showing you that we have first the diagnostic. The 0 is almost in the middle and with a balanced curve. You have a nice graphs where almost the observed network is following the same patterns of the other simulated networks in the different variables that were not included in the model. See, these models are definitely closer to what I want to see or to my observed network more than the previous models, because I increased the endogenous factors, these factors, mutual and in degree. And because we added the sample size, we increased the sample size, that also gave a better fit for the model. So yeah, so that's basically the what you can tell, that gender, women only had homophily experience. Yes, we had some formation of ties based on experience, location, international, and South region was removed later, but international students were good in terms of formation of tie, like they connect to each other. And we had a reciprocity effect in the network. And we have a centralized networks, basically. In social media would be, we indeed have some influencers in this network. Here we have a few students getting more replies. This could be the students that are popular in the classroom or something like this, okay? So these are actually some of the node attributes we had in our network. Here, you can go to this link in the StatNet GitHub. StatNet is basically the package you have. It's very useful because it's going to tell you in R which are the terms used if you want to build a model. So for example, we used node match gender to check homophily in gender. You can do different things. You can use node mix, node of actor, node of if actor, that's for in degree and out degree, many things. So you can go to this link and you can read about description of each single term and it tells you what to have or not. Okay? And these are some additional resources for you. Thank you, and I'm sorry if I was going quick because just for the sake of time at the end, I know it's a lot of material for a short period of time. So I can stop my share now, Anatoliy.
Or maybe just keep it for
okay.
a minute or two in case people have questions. And in fact, I see a couple of questions coming in. And the first one from Felipe, are there any thresholds to know what's acceptable fit in RGM?
Are there anyone? Sorry, can you repeat again? I don't
Are there
see
thresholds? Are there thresholds? Like, how do we know we stopped? Like, we reached the perfect model and we can publish the paper?
Oh, yeah. Okay. So usually what you want to have is in general, like this one, something like this one would be acceptable. You see that in these are the different in degrees. So at different levels of in degrees, you have the observed network is basically, or the simulated, basically following the model, or the model is the other way around. The simulated networks that you created are basically following the observed network. So something like this one would be accepted, but something like the one that we showed before, where you have a big chunk of many in degrees, many of these in degrees, and the network, the observed network is far away from them, like the one that we showed before. Something like this, for example, at many levels of in degrees, yeah, you have the network not following, or the model not following the simulated network. So that would be something tricky. It depends on the reviewer at the end, but yes, it's usually you want the observed network to follow that, and there's no such thing in the literature as a certain threshold where you can have at more than 3 or 4 in degrees. It's not acceptable, not necessarily. No. One thing I want to mention very quick here is that many times in big social media networks, the ergo model does not converge. The ergo model does converge with smaller networks and with networks that do not have many influencers. So one other, just for you for future reference, if one other model that works well and very similar to ergo is called the low log model, or latent ordered logistic regression models. And these are actually models that work well, very well with social media networks. We actually have a paper with the social media lab about YouTube networks, in which we looked at video recommendations. So this is one video recommending another video, and we used for it this technique of low log, which is very, very similar to work.
I think on this note, we can conclude our workshop. Thank you, everybody who came and actually stayed till the end. You have our slides from the first part that Felipe presented, from the third part, ERGM, that Deena presented, and Alessandro promised to share his slide deck as well. We will communicate it to you. And regardless, we're also recording the session, so you can rewatch it again if you want. The recording should be available next week. Have a wonderful rest of the week. Stay safe. And please keep in touch. You can always tweet at us, our Twitter accounts there, or just use SM Society hashtag. We are following that as well. So thank you, everyone. Take care.
Thank you.